Most CNC parts fit in your hand. Large CNC parts require a crane. If you have ever stood beside a machine as large as a living room table and watched it cut metal with calm precision, you have already seen large CNC machining in action. Large CNC machining refers to the production of oversized components using computer-controlled equipment built to handle parts measured in meters rather than millimeters. While typical CNC shops produce small brackets, housings, or fixtures, certain industries require structural components so large that forklifts are not enough, and overhead cranes become standard equipment. The term large is relative. A machining center with a 1x2 meter table may seem massive in a small tool shop, yet modest compared to a bridge mill traveling 20 meters along embedded rails. In practical terms, large CNC machining often involves table lengths above 3 meters, vertical strokes exceeding 1 meter, or parts heavy enough to require crane handling instead of pallet jacks. What makes large CNC machining different is not just size, it is architecture. Traditional machining centers use compact cast iron frames with enclosed work areas. Large CNC machines extend this structure dramatically. Columns may travel on floor-mounted rails. Cross rails move vertically to clear tall components. Gantry systems sweep across beds like bridge cranes, carrying powerful spindles capable of deep and controlled material removal. At this scale, physics becomes more demanding. Thermal expansion grows with length. Minor misalignment multiplies over distance. Vibration becomes harder to control. Feed rates are often reduced to maintain stability, and tool holders become longer to reach deep pockets without risking spindle damage. Thermal compensation routines are not optional. They become part of daily setup. Despite the scale, the core principle remains the same. A CNC controller reads programmed instructions and coordinates axis motion. G-code defines tool paths, speeds, accelerations, and positioning offsets. Multi-axis systems allow the tool to approach complex angles in a single setup. However, any small programming or alignment error that might be negligible on a small part can become significant when machining large surfaces. Large-scale CNC operations rely on specialized equipment. Gantry and bridge-type milling machines use a moving crossbeam that travels across rails mounted on either side of the machine bed. The gantry carries the milling head and can support interchangeable attachments such as high-speed spindles, gear-cutting heads, or right-angle heads for deep wall machining. Some advanced systems even integrate additive manufacturing heads for hybrid build and cut processes. Horizontal boring mills are another critical platform in large CNC machining. These machines use a long horizontal spindle bar capable of drilling, boring, and facing large parts without repositioning them. Heavy rotary tables allow machining of forgings weighing tens of tons, while precision scales monitor movement with extremely fine resolution. Multi-axis turning centers handle long shafts and cylindrical components that would otherwise sag under their own weight. Reinforced headstocks, steady rests, and hydrostatic bearings maintain stability during rotation. Many systems combine turning and milling capabilities, allowing complex features such as keyways or oil grooves to be machined in a single setup. Tooling and fixturing must scale accordingly. Modular tombstones and heavy-duty clamps secure oversized parts. Hydraulic clamping systems reduce manual setup effort. To minimize vibration, machinists use dampened boring bars or tungsten-filled tools to control chatter during deep cuts. Large CNC machining is not simply bigger machining. It is a system built to manage heavy materials, long travel distances, thermal variables, and structural stress while maintaining precision. It combines mechanical strength, advanced motion control, measurement systems, and disciplined process planning. In Part 2, we will examine how shops maintain accuracy across large surfaces and what risks can lead to costly mistakes in large-scale operations. If you're not following now, you may not find this explanation again.